Hello and welcome to Filling the Sink, a podcast from Catalan News. My name is Beth Cohen and today we're talking about Catalonia's supercomputer, MareNostrum. Located at the Barcelona Supercomputing Center, MareNostrum is the most powerful supercomputer in Spain. In this week's podcast, we discover how Catalonia is using its groundbreaking technology to contribute to research in fields such as weather forecasting and medicine. I'm joined today by Gerard Escaich Folch. Hello, Gerard.
Hello, Beth. How are you?
Excited to be tackling this topic. Now, Gerard, this isn't the first time that we've talked about MareNostrum. We actually did a podcast back in July 2021 in which we talked about the scientific research being done at Barcelona Supercomputing Center. But since then, I believe that MareNostrum has been updated and is now even more powerful.
Yeah, exactly. When we released the podcast, we didn't have MareNostrum 5 at the moment. It's a computer that it's updated more or less every 4 years since 2004 when MareNostrum 1 was built. And it's a public facility, it's a research center, and it's Spain's National Supercomputing Center. And it's located here in Barcelona, Avinguda Pedralbes, just a little bit north of Camp Nou.
Now, MareNostrum is part of a European network of supercomputers, right?
Yeah, I guess the European High Performance Computing Joint Undertaking. So it's kind of like a long name, or Euro HPC, JU, and it consists of 9 supercomputers across the EU. Oh, and you would say MareNostrum is the first one. No, it's not. It's named Lumi in Kajaani in Finland, and MareNostrum is the third one, just behind Leonardo's in Bologna, Italy.
So what exactly are supercomputers used for? I mean, what can a supercomputer do that your laptop can't?
Well, supercomputers are commonly used for making predictions with advanced modeling and simulations, for example, like research in many fields. So like, for example, science and engineering applications in computing, meteorological or climate events, or like predicting climate events, or like learning about them, as well as physics, like learning about how to develop an airplane, or like how to improve a car.
And MareNostrum was also important in terms of genome research, I believe.
Yeah, it also had a huge role during the COVID-19 pandemic, and it currently has. It's a way to test different elements in a simulated environment.
So I know that the MareNostrum 5 is enormous, like the size of 3 tennis courts or something. And rather than being just one powerful computer, isn't it like several connected ones?
So it's many of them combined together and connected with wires that communicate between each computer in microseconds. So it's a very fast network, and they are connected between them. So you just send part of the task to one computer, and the other computers have different tasks, and all combined work on this super powerful project that you have.
So I can imagine it's much, much, much faster than your standard computer.
Yeah, exactly. MareNostrum 5, for example, the time it takes, like the 1 hour working time for MareNostrum 5 equals 46 years of a normal laptop.
That is an incredible capacity.
Yes.
Gerard, I've been hearing talk of flops and petaflops. Now's the moment. What are they?
Well, flops is the unit of measurement used to quantify the computing power of a computer or a processor. It's measured in seconds, and it's equal to how many calculations per second can a computer do. So it just gives us an idea of how fast a computer or processor can perform these operations. So for example, Barcelona Supercomputer Centre MareNostrum 5 is 314 petaflops. A petaflop is 10 to the power of 15. Mm-hmm. And that's 314 billion operations per second. So yeah, plenty of zeros.
I'm remembering floppy disks from when I was a child, before we had things like pen drives. And of course, the floppy disk, maybe that was called a floppy disk because of flops?
I have no idea. I know flop is something that we are all going to do after this podcast.
Yes, on the sofa. And what's the centre actually like? You went, didn't you?
Yeah, I went, and it's a very beautiful building, but because it's housed in a 1857 church, Torre Girona church, over there, diagonal. It's part of a novel, Dan Brown's origin, the author of the Da Vinci Code. So one of his books takes place here in Barcelona, and we are not going to make any spoilers, but the Supercomputing Center has a key role.
So while you were there, you met the Director of Computer Applications in Science and Engineering, José María Cela Espín. His department develops scientific and engineering software to exploit supercomputing capabilities through simulations.
Yeah, for example, these simulations can be useful, as we mentioned before, in the design of a plane or a car, or like as well to introduce new fuels to reduce emissions of carbon dioxide. And one of the first things that I asked José María Cela was his day-to-day work at Barcelona Supercomputing Center. He told me that he's been working there for over 21 years now. He was part of the building team as well. And over 20 years later, as you mentioned, he's the director of the Computer Applications in Science and Engineering department.
Let's listen to that interview.
Well, we are organized in groups. Every group has a research line. For example, fluid aerodynamics. And they develop software that is able to simulate the physics in what we are interested. For example, the fluid of the air around an airplane. With this software, we are able to simulate the reality. So we can make experiments, not in the reality, we do the experiments in the computer. And this means that these experiments are faster, cheaper, and we can reproduce situations that cannot be reproduced in a laboratory. In this way, we understand the behavior of the things that we are developing, in this case, in the example, an airplane, and we can develop better airplanes.
You mentioned a little bit what you can do with the supercomputer, but is there anything that you cannot do yet?
Sure. The needs for computation in physics is incredible. For example, a combustion in the turbine of an airplane or in the engine of a car is something that requires in the order of 10 at the power 24 operations. This computer is in the order of 10 at the power 15. What this means? That when today we want to simulate the combustion, we need to make simplifications of the physics. We are not able to reproduce the reality as it is. We simplify it. We make errors. When we increase the amount of capacity in the computation, we could have more accurate models of the reality.
And how do you access this computer? Is it just like a normal laptop, or it's a special system?
No, it's like a normal laptop. These computers, they have Linux as an operative system. And from your office or your home, you connect remotely with a secure shell connection to the computer. You enter in one of the nodes of the computer, and from this node, you send the jobs to the rest of the nodes in the supercomputer.
So anyone from across the world, across Europe, or even here can access without any problem?
Sure, we are connected to all the scientific data networks in Europe, and this computer is accessed by scientists from the whole Europe.
You just mentioned that this is a research facility. I guess it's mainly for researchers. It's a public company, well, public institute, but is it also does it have private clients like Airbus or Boeing, for example, are two of the main aircrafters worldwide? I guess that investigation helps them, or it just because you like to investigate?
The facility, the computer, is open to any research group. The single condition is that the research that they develop with the computer must be published, could not be a secret research. And there is a committee to guarantee the access based in the quality of the research.
How can someone benefit of the supercomputer, or even from the quantum computing, if they don't even know how to distinguish between 4G and 5G on their phone?
Well, in the society, we are ill, we go to the hospital, and somebody put us a drug that was developed in a pharmaceutical company, and we benefit from this drug. How this drug is developed? Using numerical simulation that simulates the dynamics of the molecules of this drug, and all this work is done in a computer, in this case in a classical computer. Or you want to have a weekend in London and you take the airplane and you want to have a safety flight. Who designed the airplane to have a safety level in the flight? Somebody using computation has designed the airplane. So everything that we use in our life, from something like a TV in a home till the hospital, today requires computation. Modern engineering cannot be done without computation.
Obviously, you just switched on this MareNostrum 5 like a year and a half ago, more or less. When's MareNostrum 6 gonna be on?
Normally, a supercomputer is in the first line of computation for a period of 4 years. After these 4 years, the computer is valid, but it's not something in the top of the supercomputing capacity. So it's moved to a second level of computation. So normally it's 4 years, the time that you have at the computer really as a competitive computer in the top of the world. No?
Thank you, Gerard, for bringing us that interview. It's exciting to know that Barcelona is at the cutting edge of global research in so many fields.
Yeah, and in fact, when I was speaking with José María Cela, he told me several of the projects that they are working there. And one of them was like really struck me, which was a virtual twin city of Barcelona. So you can imagine everything that goes on in Barcelona, like everything, well, it's repeated online.
And other people in the virtual?
Everything, like traffic lights, cars, bakeries, supermarkets, your dog going for a walk, everything that goes on in Barcelona, it's exactly repeated in its virtual twin city.
How did they know about my dog? Now, José María mentioned in his interview that supercomputers usually remain competitive for a period of about 4 years. So the big question is, when is MareNostrum going to be updated? When are we going to see MareNostrum 6?
Well, more or less, some sources of BSc told us that it's already in the making. They are researching, looking for new ways. And MareNostrum 5 is going to be extended. It's going to be upgraded soon. They're going to add more computing power as well, especially focused on artificial intelligence. But MareNostrum 6, more or less, around 2027, 2028, we could be looking forward to the future of supercomputing here in Barcelona.
Well, the future is just around the corner, Gerard.
Yeah, in fact, it is. It's not around the corner. It's just I was able to see it with my own eyes. Barcelona Supercomputing Center announced a quantum computer. So yeah, we are leaving supercomputers aside. Now we are going on quantum computing, completely different.
Okay, so MareNostrum 6 is going to be a quantum computer?
No, MareNostrum 6 is going to be a supercomputer, so like lots of computers put together and connected. And then there's going to be a quantum computer. Well, there is a quantum computer now. And it's the first in Spain built with 100% European technology. And the Catalan government believes this technology is quite important. So they also announced a 43 million investment to promote quantum technology, a hub here in Catalonia, which will be led by the Catalan Photonic Science Institute in Castelldefels.
Okay, but what's the difference between a quantum computer and an ordinary computer?
Well, both are very different from classical computers that we know, or like supercomputers, and quantum computers use chips that are based on quantum mechanics principles. So yeah, we are talking about completely different. It's not IT anymore, it's quantum mechanics. And they are able to store thousands of internal states that cannot be stored in a classical computer. However, let's be clear, at the moment they are very experimental computers because they are affected by everything in the universe. And everything, I mean everything. Those protons, neutrons, electrons, or like those lights, beam of lights that the sun sends across our bodies that we are not able to like see because they are like in the atmosphere, those affect the quantum computer. So just so you have an idea, a quantum computer would look like a big cylindrical element in the middle, and in that cylinder is where they store like the chips. So it's like kind of a crane that goes up, they prepare the chips, they have a lot of different elements connected to each other, cables, cords, and it's all stored in this vacuum container. And we are going to talk about this a little bit later, but it goes from ambient temperature to absolute zero. And absolute zero is not 0 degrees. It's crazier.
It's much, much, much colder.
Yes.
So just to simplify, I understand that quantum computers need really, really, really specific conditions to be able to operate.
Yes. And instead of bits, which are what we use on our computers, 1 and 0s, they use qubits, quantum bits. We are going to talk about this a little bit later as well.
And who actually designs and builds quantum computers?
Well, the one at Barcelona Supercomputing Center, or BSC, was built by a Barcelona-based company, Kilimanjaro Quantum Tech, which was founded in 2019. They're specialized in building quantum computers, and they've also built one in Abu Dhabi's Technology Innovation Institute, aside from the ones at BSC.
Can you tell me more about Kilimanjaro Quantum Tech?
Well, it's a full-stack quantum computing company. And that means that they do everything, from the hardware, building, fabricating chips or units of quantum computers, to building software stack that connects the chip to the user, so researchers are able to operate the computer, as well as designing algorithms to run these chips, because obviously the chip, you just need some algorithms to ask them to do the task. So that's what they also do. So it's a full stack company. And in the lab, they have 3 quantum computers. 3 of them, I was able to see them, at the moment they are building one, the other one was kind of halfway built, but the largest one was fully operational.
That's fascinating. To discover more about quantum computing, we spoke to Jan Noguer. He's a quantum engineer who's been at Kilimanjaro Quantum Tech for 2 years. Let's listen to his interview.
Okay, so quantum computers are a different type of computers. So our computers, or this tablet that I have here, it works on bits, right? Bits are the classical unit of information, and it's how a computer processes information, right? A quantum computer doesn't have a bit, it has a qubit. The difference between a qubit and a bit is very essential, and is that a bit can be 0 or 1, only one of the two. And a qubit can be in a superposition of both, of 0 and 1. The good thing about qubits is that they are probabilistic, which means that, again, the bits in classical computer can have 0 or 1 values. A qubit can be 0 and 1 with a certain probability of being 0 and a probability of being 1. This is very mind-blowing for us because how can 2 things be in the same time, right? This is similar to the Schrodinger's cat, which is very, very famous, right? How they can be the cat alive and dead at the same time. So 1 bit or 2 bits can be 0, 0 or 0, 1 or 1, 0 or 1, 1. A qubit can be 0, 0 plus 0, 1 plus 1, 0 plus 1, 1. So you can imagine that this escalates a lot with the number of qubits. That's why we have this potential of solving very complex problems. So a quantum computer operates with qubits and has the potential of dealing with problems that a supercomputer or a classical computer cannot solve. And this is why everyone is pushing to have the first one.
So is there something that a quantum computer cannot do?
Yes, so a quantum computer is not good for daily tasks, for example, like opening your email, or it's not designed for that. Quantum computer is designed to solve very, very, very specific tasks that are very hard for classical computers. So it's not something that you will have on your home, for example. It's something designed for researchers and for industry value to solve very, very specific problems that are very hard to solve.
We just spoke with BSC, and one of the researchers said that the quantum computer is still experimental, and it could probably stay that way for the future to be, and probably it's even useless in some terms.
So there are 2 models I mentioned before, the digital and the analog model of quantum computation. The digital model is the one that is installed in BSC, and the problem with the digital model is that it has errors, right? It has so many errors that you need a lot of qubits in order to have a good calculation. With the analog quantum computer, which is what we do, and that's why we took a different path, you don't need that much qubits to run a problem, because you don't have these kind of errors that are intrinsic of the technology. And in BSC, right now we have a digital quantum computer, but it has been announced recently, I think 2 weeks ago, that we'll install a second quantum computer there, which is of the analog time, which is what we do.
And what benefits can it have, this digital analog quantum computer, for the research community?
For the research community, many, honestly. For example, simulating new materials, everything that involves simulating physics, which for materials, chemistry, pharmaceutical companies, this involves on simulating physics, molecules, for example. For example, the digital model is bad at simulating because of the nature of the digital model, so it's discretizing. And the analog model is continuous, so it has more facility to to deal with molecules and chemistry and stuff like this. So this is an impact for the scientific community or even the pharmaceutical, that many believe that will take the path.
And what about the end user, like the person on the street that cannot even differentiate between 4 and 5G on their phone?
Yeah, I don't think so. Quantum computers are, as I mentioned, for very specific tasks. It will not reach your home. You will not have a quantum computer because they are very expensive to build and they require a very specific setup to operate. So, for example, our quantum computers that are superconducting, which means they need to be at temperatures close to zero absolute, which is, 4 times colder than outer space. So you have in Earth something that is 4 times colder than deep space, right? So it's very sensitive to the environment and everything. So it's not something that it will reach your home at any point in the future. It's something that comes to solve some tasks that are not doable in classical computers. That's the main point. So we're building more supercomputers, are more bigger, with more connected to more power energy sources. That we saw this with AI, that more AI companies are building nuclear reactors next to their factories to feed their systems. Quantum computer comes to change all of this to a new paradigm, a new way of performing computation it's more, efficient on its basics. That's why the qubits and the bits.
Thank you for that report, Gerard. Now, with the advances in technology, I imagine that cybersecurity must be a key concern.
That's something I asked Jan Noguer and José María Cela, and in fact, Barcelona Supercomputing Center has been victim of several cybersecurity attacks, even though not successful ones. And quantum computing is also a key element on cybersecurity because it's going to change everything that we know so far. Encryption at the moment is going to be completely redefined.
Okay, let's hear what José María Cela and Jan Noguer have to say on the issue.
Is it possible that in the near future we have some hackers or some groups of hackers using quantum computing to target key infrastructures worldwide?
Sure. When you have a technology, this technology is for everybody, for the good guys and for the bad guys. So if quantum computers become a reality, for sure criminal organizations will try to use it to break the security in the communications, in the banks, in all the digital information that we have.
If someone has a quantum computer operational in their basement and hasn't told anyone, this person can read any message that today we're encrypting. Because the algorithm that encrypts all data is based on, knowing the prime factors of a number. So for example, if I tell you what are the prime factors of 21, you know it's 7 times 3. But if I tell you the prime numbers of 1 million to 1,000, you don't know it. And the fact is that a computer doesn't know it either, doesn't know how to calculate. So that's this basic operation, mathematical operation, it's what encrypts everything data. But there exists an algorithm for a quantum computer that is able to do this calculation very, very fast. So that's the reason why, I think every government in Earth is investing on this, because they are concerned about the security,
And how, a little bit related to this, how close are we to learn the credit card number of someone else?
We are far. We're still far. But we'll see, depending on how the field evolves. The more optimistic, say 5 to 10 years, and the less, say to 15 to 30. So nobody really knows.
Let's hope that we can install effective cybersecurity measures to stay just one step ahead of the hackers. It's clear that Barcelona has become an important location in terms of cutting-edge technology. In fact, we're going to be hosting the Mobile World Congress in just a few days' time. It is the largest and the most influential connectivity event in the world, and it's going to be taking place from Monday the 3rd to Thursday the 6th of March at the Fira de Barcelona. Gerard, are you going?
Yeah, all Catalan News is going to go, so make sure to stay tuned at catalannews.com for all the new technology that people are going to be able to experience at Mobile World Congress. But just a quick hint on what to expect. Quantum technology, we've been talking about it in this podcast, and it's going to have a key role at the MWC. but also the most fun things, self-driving buses and foldable phones. There are going to be almost 50 Catalan companies at the Mobile World Congress at MWC, and 50 more startups are going to take place at the 4 Years From Now event.
So stay tuned to Catalan News to find out more. Gerard, as a science fiction writer William Gibson says, the future is now. It's time for the Catalan phrase of the week. Gerard, what do we have?
Well, we heard about that story during our interviews, Schrödinger's cat, so aquí hi ha gat amagat.
Ah, okay, so there is a cat closed in here.
Yeah, exactly, so there's a mystery to discover, kind of Dan Brown's origin novel, kind of like what's going to happen with quantum technology or supercomputers. Aquí hi ha gat amagat.
But is it Schrödinger's cat?
Who knows? Is it or is not at the same time?
That's all we have time for today. Thank you for listening. Make sure to subscribe to Filling the Sink wherever you get your podcasts if you haven't done so already. Thank you to José María Cela and Jan Nogué for speaking with us. And thanks to you, Gerard.
It's been a pleasure learning about supercomputers and quantum technology.
We'll be back again next Saturday with another exciting episode of Filling the Sink. On behalf of all of the team here at Catalan News, I'm Beth Cohen, wishing you a great weekend. Fins aviat. Adeu.